Welcome to Change by Design, the podcast where we shine a spotlight on engineering transformation. I'm your host, Chad Jackson, and each week we dive deep with leaders driving real change in the world of engineering. From breaking down barriers to challenging the status quo to fostering cultures of innovation and resilience, our guests share their journeys, lessons learned, and actionable insights to help you become the catalyst for positive change in your organization. Whether you're an engineer, an executive, or simply passionate about making a difference, you're in the right place. Get ready to be inspired, empowered, and equipped to engineer a better future, one change at a time. Ebele Okochar and Pete Oliver-Krueger, thanks for joining the show.
Glad to be here. Thanks for having us.
Thanks for having us.
Absolutely, yeah. So I think a good place to start is if you could give our listeners and viewers a little bit of an overview about what you're doing right now. You know, where you're at, what kind of work are you all doing, what kind of projects you're working on. Who wants to start first?
I'll start. Yeah, so we work with where our company's called Organizational Mindset Mapping. But basically, we are coaches and trainers. And so we work with a lot of different companies, most recently a lot in the manufacturing space. And we kind of come in through the project management office, but we work across all the various different departments, and we have backgrounds in working with all the various different parts of organizations.
Okay, excellent. And Bailey?
Yeah, absolutely. So, Peter and I, when we came together to put OMM together, we just realized that companies have problems, especially in the hardware space. And we've worked and we've tested it. And we know several others are looking for solutions that are common in the hardware space. So basically, that's what our offer is at the moment, solving problems that are common in the manufacturing setting.
Mm-hmm. This is great. Excellent. Yeah. So the focus today is going to be on hardware development and specifically, the application of Agile, which has typically been applied to the software development space. But we're going to be exploring, there's a lot of companies exploring the application of that to hardware development. And these two have been right in the middle of that, which is great. So before we get there, let's talk about your origin story. Like, how did you get here? Like, this is unusual, right? I mean, to kind of be a coaching and kind of a consulting type of company around hardware development. How did you arrive here? What was the path?
I'll go first. So I'm a relationship management person. From the very beginning, I've been in places where I've been client facing. So I've always understood that clients like solutions. Just give them a solution, keep them happy. If you are able to provide something that solves the problem, then you have a client that is happy. The client comes back, refers you. So I've always been in that space where I've always had to deal with clients, deal with their needs, understanding from the client's point of view. So eventually I found myself pivoting into projects from relationship management, and I started going to the back end where we are putting together solutions for the clients. So, but I had a specific role which was more in the supply chain area, but there was a gap. And then I just realized that I found myself filling this gap because there was no system integrator. And I needed to, I am a system thinker. So I could see the gaps, and every other person was like, oh, just working normal. I started filling that role, and then that's how I became a project manager. I got certified, actually, PMP certified. And
Congrats.
eventually I moved into Agile because by my nature, always curious, looking for solution. I just eventually pivoted naturally, actually, into the Agile ways of working. But I would really say I was basically led into it because I was trying to fill a gap that was obvious and no one else, no man's job is if you don't assign a role, it's no man's job. Yeah.
Very good. Excellent. Congrats on the certification, by the way. That's good stuff.
Thank you.
Yeah. Pete, what's your path?
I kind of came in maybe from the opposite direction. So I started off in the engineering space. So my dad was actually a NASA engineer, as were my uncles and a variety of other different folks. And so I actually went into college wanting to get into robotics. So I went to Carnegie Mellon and got a degree in electrical computer engineering. Uh, but at the same time, when I was there, I discovered and fell in love with acting. So I came out doing this parallel path through life. And the interactions with people really made a huge difference for me. So in the evenings, I'd be off, doing acting and learning how to connect with people and understand characters and do all that kind of stuff. And then during the day, I'd be doing engineering stuff. And I found out that I just really liked the psychology portion of stuff. So I started following the people. So I went from being an engineer, like doing operations and telecommunications and a variety of different things just to get started, into actually doing the working with the other people on the teams and getting into usability testing and going out and looking at customers. That led me into design. I never finished it, but I started a graphic design degree. That got me over into doing management. Then I had this great idea for a company based on all the work I've been doing. I became an entrepreneur. And that's when I discovered the difference between having a great idea and selling a great idea. Uh, and that's when I started getting into things like lean startup. And I started becoming a product coach because I had people that would come to me, look for these things, and they kept asking me to build the wrong things. And so I was like, hey, have you heard about this stuff? And then I would teach them about talking to customers and research. And so that brought me back around, and people were like, hey, can you do that with my company? Can you teach me how to do this other thing? Can you teach me how to do all these other different things? So I was ended up being very agile, both in my career and just being sort of all over the place. But also when I got there, I didn't have any like large agile training, but people were like, you think in a very agile way. And so then I went off and like took the training and took the certifications and did all the stuff. And I was like, oh yeah, like this is what I naturally do, is all of this stuff. And now I had the certifications so that other people knew that I knew what I was talking about. Um, but yeah, and then in parallel, I had the whole theater thing. So I was a musician and an actor and a stagehand and a stage manager and a set designer and director, and then eventually became an acting teacher. And everything in my life has been a pairing and a merging of those two things in parallel.
Good stuff. Wow. One thing I noticed with both of you, you both seem to have some soft skills as part of your tool set, right? And I think that's, actually we've come across that a lot, both in terms of engineering and product development processes, but also in terms of engineering transformation and initiatives. You need a lot of soft skills to be successful there. So let's shift gears a little bit. Let's talk about change agents. I have the impression that since you all are coaches, especially around Agile for hardware, you're in the midst of a lot of change initiatives, and you interact with a lot of change agents. So I'm going to throw this out to you. How would you define a change agent? Let's start there.
I would say that a change agent is somebody who's bringing new ideas into a team. So if it's not about just taking what's there and sort of reshaping it, I think what really makes a change agent is their ability to go out, look at other things in other places, and bring some of those ideas back into the team. But then that's just the first half of it. The second half of it is, does those ideas actually work here in this organization, in this team, with these people? And I feel like that's really the large portion of that change agent role, is how do you integrate these new ideas into existing spaces? So you're the traveler.
Although to Pete's point, coming in as a change agent, some organizations would speak to, say, the team and go, we have this problem. So let's bring in people who know how to do it. But in some cases, there's really no defined problem. They just want to change because it's the new norm that is everywhere. Let's go ahead and implement this change. Everyone is doing it. Why not us? So as the change agent, when we come in, we help them to first of all get to the root cause of why do you really think you need it. So at the leadership level, help them to understand the reason for the change. They might not know it in the beginning, but yeah, you help them see it when you come in.
Fascinating. Yeah. So I see a lot of discussions on LinkedIn, and I like to be very active on LinkedIn. And there's always this, I find it really fascinating. You always see frankly, a lot of software providers, and sometimes a lot of consultants talking about technology, right? And it's always about that tech side, but the people side are consistently where people run into the biggest stumbling blocks, the biggest barriers. And Pete, to your point you mentioned earlier, how do you take this vision with theoretical value and kind of mold it into the shape of your organization? So I find that fascinating. So let's talk a little bit about success factors in change agents. Like, what do you think are some of the key characteristics and traits of a change agent that you've seen be wildly successful and some that have not been wildly successful or wildly fail? Be curious to get your perspective there.
Yeah, I think there's two cores that make any good change happen. And one of them is collaboration, and the other one is problems. So one of the things that we run into is, so in the first one, space, just like having time on the calendars. Like usually the thing that blocks the most progress is you can't get the people together that you need. Something needs to happen, and that person's not available, and then you need this person over here, and then that person, and then you might go across weeks to months to sometimes years to get an answer to the thing that you're looking for because people don't prioritize collaboration. And that's one of the core things that's sort of, I think, different, or at least at the center of Agile. And then the other thing that we do that's so different, I think, than others is we focus on solving problems versus implementing solutions. And to go back to like what you were saying and Bailey as well, is that oftentimes we're brought into an organization where they say, you know what we want? We want you to come in and we heard about this thing. We want you to teach us this, and this. And I've done those, and you get all the way through and you teach all the different things. And then they look at that and they're like, wait, but that didn't solve our problem.
Yeah.
And then they tell you what the problem is. And then we're like,
Yeah.
oh, if that's your problem, yeah, none of these things were going to solve that. Let me tell you what is going to solve your problem. You need to do this, and this. And then we set up that stuff. So we have a big portion of what we do is we go problems first. The goal is to get the solutions. But first, we want to identify what are the problems? What are the things that we want to see go away in this implementation? And then we, as the change agents bringing new ideas from the outside, are bringing in things that can solve those problems. Because honestly, if they were going to solve those problems, they would have done so already. So there's something inside the culture and inside of the team that is preventing them from being able to solve those problems. And then we bring in some outside ideas that are new and have a chance to make a change.
An additional point to Pete's response is the fact that for a very important success factor is the leadership involvement. Because when leaders are involved in the transformation, then you'll be able to have things move. But if they don't even, if the mindset is not even bought in, that's a major, major setback. So, yeah, very important that they're involved.
Yeah, this is really interesting. I mean, so from our perspective, when we look at readiness for an initiative, we look at, is there value? Is there business value? Are you going to have a business outcome? Are you solving problems? And then we look at risks. And risk can include all kinds of things, culture, attitude towards change, bandwidth. You mentioned another one there, Pete. That's another big one. If you have no bandwidth to dedicate towards a change, that's a pretty big risk. Sure. It's going to mitigate your ability to realize value. So those are some of the big ones, and having leadership involved, especially on the value. Like if you don't, as an engineering leader, if you don't identify, okay, this is the outcome we want at the end of this initiative, the net change, then you're definitely not going to achieve it because you haven't identified it. How much work do you do with the executive leaders to answer some of those key questions up front versus you walk in and the engineering leaders have already figured out, this is the business outcome. We think the change manifests this way. This is tactically the way to go execute it. I'm interested to get your perspective on, in the number of organizations you engage, how many fall into each bucket? Like, what are the percentages? What would you say?
Yeah, I'm curious about percentages. I mean, there's a difference in the outcome based upon that approach. So we've been brought into organizations where it's just like, hey, go do this thing with the teams. We'll talk to you in a year. And when we get to talk with leadership, it can be a very different kind of thing. So that's actually the origin. So I actually wrote a book. It's called Shift from Product to People. And it is about the leadership portion of it. So it's written from the point of view of the leaders. So it's actually a novel written like Game of Thrones, or The Expanse. And so every chapter changes perspective so that you can go through the different parts of the organization and understand how each person sees the world differently. And then how your job as managers and leaders is about bringing the pieces together and being part of the change. And what does that mean, both from a people or psychological standpoint, as well as an engineering standpoint. And we can get that when we can work with the leaders, when we can start at the top. That's been some of our most successful implementations. So preferably, like if I've started in walking at the very top and dealing with the C staff to the VP staff and giving them introduction down into their managers, and then from there down into the teams. And those are much better integrated rollouts than if they bring us into the team at first, and then we have to get on the manager's calendar and then move that way up, and then talk to that person in finance and talk to that person in the VP level. And that goes much slower if you have to climb the ladder than if you start at the top.
Bearing in mind that the budget most times sits with them at a C-suite, the how long you stay or what exactly you are doing is determined by. So we want to first of all have an idea of what does success look like from their point of view. So if we have that idea of what success looks like, then we know we are working to create value that they can relate to. Otherwise, you're going to find it very difficult to justify the ROI.
And I think if you're talking
that's
to
great.
the leaders, like what they care about is that return on the investment. And that's really why starting at the top works. It goes faster. It's cheaper. You get more value. You get more delivery out of that stuff if they're involved throughout the process. And that's the thing that we try to, share that message in, that if you're not here, that's actually one of the reasons why things are slowing down, why things aren't getting done, why things aren't getting out there fast enough. We can minimize your time because you're very busy. But if you're not available at all, everything starts to slow down.
Yes. Yep. Yeah. Yeah. For executives, that is a significant challenge, for sure. Let's talk about Agile. A lot of people are very familiar, especially from hardware development, with the waterfall. approach, right?
Mhm.
The progressive phases, one lined up to the end of the other. Mhm. Let's back up though. So, like at the highest level, how would you describe the difference between agile and waterfall?
This is my sort of quick origin story on Agile, which is that there's a bunch of people who just kind of looked around and noticed that they were more productive than other teams, but not like just a little bit more productive, like 5 times, 10 times more productive. And so they were like, what is it about what we do? Like, we're not different than these other folks, but we're having better approaches. And eventually they found other people that were like them. And then they came together and they started sharing some ideas. And then for Agile, they got together at this snow resort in Snowbird, Utah. And they came together and had a conversation. They built the Agile Manifesto. But the way they did is they looked at what did they have in common. And if they didn't all do it, it didn't go in. And so what they ended up doing was bringing together these opportunities for sharing and testing ideas, and then they brought it back and forth, um, and they swapped ideas. Does my idea work in your organization? Oh, it does. Well, maybe it does or doesn't in this situation. What does it look like in this industry? What does it look like in that organization? And they started building this community of sharing knowledge of just better ways to work that are much more productive. And so that is at the core of Agile. And so Agile really picked up some good ideas from Waterfall, some good ideas from Lean, some good ideas from design thinking, good ideas from, Lean startup, from all of these other different ways. And so you'll see a lot of things that are inside of Waterfall. But what Agile did was really focus on how do we make sure this is delivering the highest amount of value as quickly as possible.
Mm-hmm.
Yeah. We don't like to pitch them against the other because in most cases you find that the if you walk into a team where a project manager has been doing a good job, you don't want to sound like, oh, gonna toss all your ideas away and just go agile. No, they've been doing great things, and that's a very fast way to get resistance. They've been doing great things, so we don't pit them against the other. We like to use certain sound bites that come across that is easier to absorb. One of the agile sound bites that we like is creating smaller pieces of work for faster cycles of feedback,
Yeah. Okay.
because the feedback is what we really need coming quicker. How can we create work to be smaller so the feedback can be faster? Instead of months, if you were having months, can you make it to weeks? From weeks, bring it down to maybe days, hours. That's just what we want to do. So
Yeah.
that's the
Good.
yeah.
I might clarify a bit here, which is to say that this is not all Agile coaches, just we don't make a distinction between Agile and Waterfall, and we integrate all that stuff in. There's a warning
Okay.
out there that there are people in the Agile industry who are like, Waterfall is evil, da, 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 da. We don't find that pretty productive.
Yeah.
Yeah. Okay. Fair enough. Fair enough. So I'd like to dive in a little bit around software development versus hardware development. If you're doing any kind of software development, it doesn't matter if it's for vehicles or aircraft or software SaaS platforms. A lot of people are using Agile today, right? It's in the water. It's everywhere. I'd love to hear a little bit about the pressure or kind of the disjunction between hardware and software. In a little bit more context, I've seen a lot of manufacturing companies struggle with how to reconcile the pace of development with software, which is changing very, very, very fast, right? It's based in Agile versus hardware, which is much slower cycles. But eventually they have to come together in systems that must deliver features. So can you talk to me a little bit about what's going on in the industry where there's a lot more software going into hardware-based products and people are trying to reconcile? Like, what are you seeing there? What are the trends? What's conflict? What's the barrier? What are the problems that people are experiencing?
Let me start with another soundbite, which is um, the hardware It's just software in slow motion.
Okay. All right.
The
I like that.
the agile principles are the same. The application just might be a bit drawn out, and then knowing how and where to apply them. So I would say in the software setting, it's easier to plan, you build, you test, you deploy. But that's not easy in the hardware setting, because before what is deploy in hardware? It means you are doing mass production. Eventually, that gets distributed. Now, mass production, there's so much going into it, which is industrialization, setting up the factory. So it's much more complex than a typical software setting. Pete, I don't know if you want to dive down into.
Yeah, that was one of our phrases. So we have a colleague, Jim D'Amato, and he loves to say, "Agile is agile," and he picked it up from Joe Justice, who was one of the pioneers of doing agile in the hardware space. And we've found this to be the same thing, and so we've kind of developed our own spin on a bunch of these things, but everything kind of translates in a slower sense. So
Okay.
if you take the work that needs to be delivered and you're thinking about building something and building an actual manufacturing line and getting it set up and getting people trained and resolved and ordering and supply chains and all that kind of stuff, to do a deploy like that is years worth of work. To do a deploy in software is you hit a button and it goes. You might spend some time in sort of building up these sorts of things, but there's some automations in here. And it's not to say that manufacturing doesn't have automations. It's got robots. It has been doing a lot of these things. We actually took a lot of great ideas from the manufacturing space, brought them over into the software space to improve what we're doing on it. But you can't change the fact that this person over here working on that thing has a PhD in electrical engineering, and that person has a master's in mechanical engineering, and this person has been doing this risk management stuff for about 30 years. There is that level of expertise and deep dive is not paralleled in software. In software, we have a lot of the same types of thinking. Like you've got a person in the database side who's doing that with software. You've got a person in testing who's doing that with software. You've got a person who's doing back end or middle tier in software and front end in software. Everybody's doing the same job. They just might have some different specializations. And so they can do a lot of things really fast and really quickly because they all talk the same language. And that's just not possible in hardware. But at the same time, there are some things that are very possible in hardware, like we talk about an agile of sprints. Like the sprint is basically a cycle of feedback. And people say in hardware, you can't do 2-week sprints. We have done that.
Yeah.
Because it's all about what work you're doing, and it's about the
Yeah.
feedback cycle. It's about setting a time and choosing to say, we are going to come together. We're going to plan what we're going to do for the next 2 weeks. Then we're going to go off and do our work. And then we're going to come back in 2 weeks and see where we are and see what we want to do for the next 2 weeks. That's all a sprint is. In software, they get into all these sorts of things and they're trying to do deliveries and they're trying to do a whole kinds of things you can't do in manufacturing inside that 2 weeks. That's fine.
Sure.
That's a software thing. But the concept doesn't change. You get together, you do some work, go away, do some work, come back together again. Same thing with the daily stand-ups. People are like, why would I need to talk to people on a daily basis for stuff? And so they resisted us every single time we sort of brought in this concept. But we went back to the problems. And for example, we said, what is it that you are having problems with? And people are like, well, I'm stuck. I need this from so-and-so. So I'm like, great. Tomorrow you're going to bring that up at the daily stand-up. And that person's going to hear that you need this. And then you're going to go off and solve it. And then you come up with something else and you come back tomorrow and you're going to, and they started realizing the daily stand-up isn't this ritual of what did I do yesterday, and what am I going to get done today? It was the point to bring up your problems. And then have that chance to have a collaboration point. So like every concept inside of Agile transfers over, and it really is that Agile is Agile, but it integrates or it operates differently in hardware than it does in software. And so that's what we help people to sort of realize is what is that difference, what translates and what doesn't.
Mhm.
The question we get a lot, and I need to bring that up, which is the fact that software, we plan for what we know now and quickly work on it, move on, and then iterate with new information. In hardware, what we know now, we really actually need to plan it out a little. So what is a one quarter work in the software setting that you are working with? For hardware, you need to actually build out that plan to have a big picture view, because there are so many moving variables, which is always the problem in hardware. How do you know what you need to do right now if you want to optimize your execution? So this is where the technique that Peter and I and Jim, what we came up with, which was the IDD, came into place. That game changer that we got in hardware, being able to have that system view from the very end to the beginning, that we are able to know what is the most important to work on now if we're going to hit that date of deployment.
Mhm.
So that
Good
brings us
stuff.
into what needs to go into this sprint and what needs to go into next sprint.
That's good
Yeah.
stuff.
And
So
IDD
what?
stands for industrialization driven development is what the
Okay.
IDD acronym means.
Industrialization driven development. Okay. All right. Makes sense. Okay. Something that we've kind of circled around a little bit. It's kind of been embedded in the conversation, but I'd like to make it more explicit. Is this concept of frequent prototypes or frequent builds? I would say, and that's the concept that software, you can do daily builds. You can compile it, you can run it through a unit test, and then maybe during your sprint for the week, at the end of the week, you're doing something more complex for verification and validation. I'd like to talk a little bit about that in the world of hardware, because we've mentioned it a couple of times. I'd like you to talk about, why is it important to build physical prototype of this thing? Why is that crucial? And what role, if any, does digital and simulation and models play? And even the hybrid mixes of digital physical. Talk me through that a little bit. I mean, if you could start with frequent prototypes and how it applies, and then merge in the rest of it, that would be great.
Yeah, I think that was one of the difficult situations to describe in a hardware context. Like, we knew this was going to work. I'm a builder. I've built things, on my workbench, in the matter of a couple of, days or weeks. And I know those engineers have too. So we walked into, for example, one of the teams from a couple of years ago, and we said, all right, we're going to do this build concept. So we just need you to build a version of this product. And of course, they said, oh, we can't do that. I don't have this piece, that piece in here. We haven't designed this whole section, hasn't even been designed yet. And we said, well, what can you put together? Like, let's just take those pieces and put all those, whatever was done, go ahead and build that. And then there was a couple of more, days to weeks of angst. Well, we can't do that. We're going to try to do this. No, that's not possible. I don't have somebody that can do that. I need to order some parts. And we're like, okay, go ahead. Order the parts. Let's bring that together. Let's get the person that we need who can do the building of the pieces and put it together. And we just kind of kept them at it. And eventually, over the course of about a month, they put together a full version of it from end to end, and not complete, but functional. And so they had that little product, and they put it on a little testing board, where they could put their leads on it and get the signals and talk about stuff. And it was a smart device, and so they could load up their software onto the chip and let it run. And we had 3 things that popped out of that were completely unexpected. So the first was they loaded up the software onto the chip and everything just shut off.
Sorry, it's not actually funny. It's but it is, right?
Yeah. It became one of those things that was funny over time, but like you're just like, what? And so they had to go in and take a look at the different things, and they had been designing in a software bubble in the cloud, and all of it made sense and all of it was logical. But they said there was a piece of software and said that if there's no power on this pin, stop. Well, it was a prototype. There's no power on that pin. So everything just stopped.
Well, it did what you told it, what you programmed it to do, right?
Exactly. So going back in and looking at that and sort of hiring it, hooking that up to the hardware, they started thinking about the entire process through. How does the entire thing function? So even if this step is missing, how does it get to the next step? And are we working on the right steps in the right order? Because if we don't even know how this is going to work and we're building something that's based off of this, and then this completely changes, everything we've done here is going to be redesigned. So by putting all the pieces together, they started to get a picture of what was most important to do in which order. Because if you did the wrong thing in the wrong order, you would have a ton of rework to do later. And so that was the first thing that was great for a build. Second thing was the electrical engineer looked at this and was like, I can test this. And he's like, I got some pieces here that's already together. And he ran over to the lab and he did, extreme heat testing and the back and forth testing and, extreme cold testing and a variety of other things. And they discovered that there were certain pieces of materials that they had chosen that were not going to work. And so then they had to change that and they had to swap it and they had to come up with new things. But they discovered that in the beginning of the process, in the first couple of months of the project, instead of when it normally would have been tested, which would have been 2 or 3 years in, after everything had been done, after everything had been built, after everything had been designed, and it was getting down into the industrialization side phase when it's too late to make those key important changes. And the third thing that they discovered was the product people said, I'm going to go take this and show this to some customers and see what they think about it.
Yep.
Actually, we pushed them a little bit on that. I had somebody there on the product side who had done customer discovery, and I was like, you can show this to people. And the engineers were like, no, it's not done. It's done. You can't show it to anybody. And they built basically this demo box that showed what would work. And they took the product itself, hacked together with a few other different things to then create an experience for the customer. And then they went out and they did some tests with the customer, with the sales staff, showed them all of this stuff. And the customers were going through and they're like, oh, I like this. And they're like, but what the heck is that? I don't want that. And this product had like this screen on it. And it was this big innovative thing and it had taken a lot of work. And it was one of the reasons that they brought in the software people. And they were like, get this thing off of here. Like, this is of no use to me. And it's going to make my customers want to get in and mess around with things, which is then going to make my job even worse. And through that process, they realized that this thing that somebody thought was going to be a game changer and everybody in the field was going to be like, oh my God, this is awesome. The customer actually had the exact opposite reaction. And by taking that out, they were able to speed things up. And they were able to move faster, and they didn't have to code for this new screen piece that was in there. And the architecture simplified, and the materials simplified, and the cost of the product went down. And there was all of these things that got better because they did a build in 1 month, and they didn't even know that those 3 things were going to happen. But the build forced that process and bubbled up those problems faster than anything else that they had ever done.
Yeah.
So a major call out was the fact that initially there was no room, or should I, enablement for prototyping. So when we came in, we started pushing for there to be availability of materials for easy prototyping. So enabling a laboratory to quickly come up with a prototype had to be done. So you have to create an enabling environment for prototyping. That's one. Because
Mhm.
in hardware, it's a lot of materials to be sourced. So create that environment where prototyping can easily be pushed for. That's one. One of the things, Pete, that we didn't mention was the fact that while they were testing, they realized that there was a material that is not the original material, we just substituted and it passed.
Mm.
And they go, oh, but this is cheaper. And it still meets standard. And and they go, oh, so why can't we replicate this all over? Because it was way cheaper. But it still passed the standard test because these are regulated environments. So if it passes, then why are we not using it then? But that only came up because they could prototype. So afterward,
Yeah.
every time they did a new design, they will update with a new build and testing it. So testing became frequent. That was how we
Mhm.
could get the right feedback from the right stakeholder.
Yeah. What a great story. There. Okay, this is something I try to talk about a lot. The decisions made in engineering directly affect the margin,
Absolutely.
obviously, of the company, but you're talking about the margin for each product made, right? You just lower the product cost. If you keep the same price, you have greater margin now, right? So the fiscal impact of the engineering decisions, it's direct and it's powerful. Hey, this is a great story about exposing and learning more early on. That's really crucial. So there's
Yeah.
actually one note. There's a couple observations I want to bring up. You're actually talking about agile for hardware software systems. If it was just agile for hardware only, we'd be talking about mechanical components or maybe a board absent software, right? But ultimately, you're talking about top level systems, getting Target Electronics to work with software to work with the mechanical housing and everything else. So I, I think there might be a little bit of a misnomer around agile for hardware versus agile for hardware software systems. So that's one thing. And the other thing is, and I want to lead into a discussion about the engineering V, right? You define your system level stuff up here, you travel all the way down, get into detailed design, and you validate from kind of a bottoms up perspective, and you validate the system at the end all the way over here, but there's a lot of time in between here that is typically passed. And what you all are talking about is kind of filling the V there, right? You're doing continuous kind of verification and validation of the software, which I think is pretty fascinating. So can you take a few more minutes and talk about that shift? Do you run into organizations that say the engineering V is tried and true? We've been doing it for 50 years or whatever. That needs to be our mantra, and getting them to shift to this continuous progressive verification and validation through frequent prototypes.
So one major factor that Agile helps with is giving visibility. Now, visibility helps with d- taking informed decisions. So using IDD, which is the industrialization driven development, would roadmap your product. Now, it doesn't matter if it's a dumb product that is it's not a smart product. There's no software in it. If it's fully dumb product or if it's a smart product, it's the same. So if we draw out your roadmap, then it becomes visible. Remember, Pete mentioned something earlier, which was collaboration. We bring everyone. So we don't isolate the engineers and let them do their design. We would bring in the person who would scale the products. Because the design for scaling is done, it matters. So his opinion could shape how engineers do the design. Bring everyone into the room. So when we do the roadmap, and then it's obvious that if we shift this part here, it could save us 3 months if you design first. Once you design this first, then I can place the PO at this junction, and then I get it in by this time. So granting visibility is system view visibility, gives us our risk view upfront. Everyone is there, and then you can take optimized decisions because you can see. So that's the big picture that IDD gives, which is the differentiating factor. The fact that you can see from design all the way to deploy, it gives you option to be able to take informed decisions and go for the best strategy. So if your strategy is you want to optimize your time to markets, then you take and design to favor time to market. If your strategy that you have chosen is you want to do time to market and lower costs, then you design in that favor because you can see it now. It's easier to move things because you can see the implication. If I move it back here, what's the implication? It's quite obvious.
Gotcha.
Yeah.
And Pete,
And to sort of echo what Ebele was saying, this isn't just software and hardware integrated. It is just hardware. It is just the work that's happening. Anything, the work that needs to get done. We are often brought in when there's an integration point because the software people show up and they're like, "Hey, we've been doing Agile. You should do what we do." And then they're like, "What does this mean?" And then we talk to that. But we also have worked on many projects that don't have any software at all, that are not included in that. And you talk about the V, and I did the V for quite a while. And I was taught that, in college, and we did all the different portions of it. And then like over time, I started learning things and I started noticing that there were differences in sort of the history of this. That if you go back, like I listened to my dad tell stories inside of NASA, and it's not a V, it's kind of two parallel sides of a V. And they were doing that, and then somebody said, "Oh, we better put some more time in. Oh, we better put some more time in." And they started expanding these parallel paths until they turned into a V. And a lot of what we have in PMI and project management actually came from NASA, but it came from NASA post-disasters, not pre-disasters.
Interesting. Okay.
So if you go look at what they were doing in like the Apollo missions and a variety of these different things, it was, we have this idea. Okay, how are we going to test it? Okay, this leads to this idea. Okay, how are we going to test it? That leads to this idea. Okay, how are we going to test it? And they would prototype and build at each step along the way, and then their prototypes would get more and more complex. My dad actually was just here for Thanksgiving, and he told a story about putting together this satellite. And when the satellite came together and there was a problem, they had to deconstruct the entire satellite and take it apart in order to get into the portion of it. And then that would take like a week, and then you had to order the parts, and then you had to bring it back in and reconstruct it and put it all together. And he said, "All right, so we've got a design that we're going to have to take apart at the end." So he actually went in and designed an architecture that allowed every portion of the satellite to come in and plug in at the center, knowing that at the end, if anything went wrong, we would need to pull it out, fix it, and put it back in.
Yeah.
And so he actually did an early prototype design on interface, not cards in the software sense, but like a plugin where it would self-align as it plugged in to when you pulled it out and then you put it back in, it would self-align. Because if you messed up anything, when you put that back in, that's like a multi-million-dollar satellite that is now dead, and you got to take it apart and you got to figure out what's going on. And so at each stage, it's actually better to not do a V. It's actually better to do these parallel things. And so we work with teams like this and say, all right, so we got a product idea. We're going to take that immediately out to the customers and see if that's right. How are we going to test this? And then we actually get feedback from them. All right, so now we got something the customers want. So now we're going to do a system design and look at this stuff. So now we're going to go directly to the industrialization people and say, could you actually build this if we put it together in this sort of a way? Oh, we can't for this reasons. We can't. Da, 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 da. And now those Indus people are talking with the designers up front. And then we drill down into a sub piece. And those people are doing conversations with the risk people and with the labs. Can you build this subcomponent? And then drills down even further, and they're talking to the supply chain. So at each step along the way, the verification is just right after the design. And then you drill down and make sure you didn't break the previous verification, and then design the next verification. Then drill down and make sure you didn't break the previous stuff, then drill and go to the next step. And so this parallel path is actually faster and more effective. And you go back and you look at what they did in the Apollo in the earlier days, and that is exactly what they did. Every thought and every idea that they had, they immediately said, how can we test it? They prototyped it. They figured out it was going to work, and then they went deeper. And so that was some learning that for me was very kind of profound. And once I tested it on my own stuff and building my own things, and I could go faster, that was one of the things that made me 5 to 10 times faster than everybody else. And so people say, hey, we can't break the V. And I'm like, can't we? Let's give it a try. Try it once and see how it works. They're like, well, we can't have this, we can't have risk. We can't have this thing break. We can't do this. I'm like, great. So bring up the risk when it occurs. And now we're going to solve the risk right now. That's another big huge thing about risk. Most of the time, people are logging risk and people are owning risk and they're building all this stuff up. And then at the end, they try to solve all the risk, and that's way too late. You do everything in parallel.
Yeah, gotcha. Let's take a break here for just 1 second. We're at 10:30. Do you all have some more time to talk?
I do.
I do.
Okay. All right. 1 second. I need to send a message to someone that I'm not going to make my next meeting. Give me just 1 second. Okay. Yeah, let's continue on. Fascinating discussion. Sorry, let me get Teams out of the way here. So I find this a fascinating counterpoint to what has been discussed in the industry for the last decade. And that push has been towards a digital first mentality, right? So build models, run simulations, do that in a digital environment until you've gotten everything perfect, and you build one prototype and that's it. And then you move on and you avoid these expensive iterations on prototypes. Actually, I've written a ton about this. But one of the things I've seen is, especially with software in these manufacturers, they hit that prototype phase and everything grinds to a halt because there's so many integration issues and unkunks, right? So unknown unknowns that come up from a systems perspective. So this shift, I see a lot of companies do it because they have so many problems with that digital first mentality. So can you talk a little bit about that? And I'd love to hear specifically, how does digital work in this context? What role does it have to play? Digital verification versus physical validation. Talk to me a little bit about that balance as well.
Zero.
I'd say that one of the things that I see often is the either or mindset. That we either are going to do prototype builds or we're going to do digital. And every time I see an either or, it's never an either or. It's like the debate of nurture versus nature. And there are people who will go to the mat and fight you back and forth to say, nope, here's the reason why it's all nature, 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 nature. Here's the reason why it's all nurture, 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 nurture. And I just look at them and I'm like, you guys both have great ideas. And that makes sense and you can prove it out because it's both nature and nurture.
Okay.
And the same thing I find here is within the engineering is that the digital twins and this a way to simulate things that we're designing on and let the computer to be able to run a bunch of things that normally we might have to spend weeks and weeks and weeks building something out in order to get to the same result. Huge advantage. Definitely should do digital twins. There's huge, great benefits that you get out of that. And you should build it physically at the same time. Just don't make it an either or. Do both. And you're going to get both things in the same, we want to get into these prototype pieces and stage things out. And when you have an idea, the fastest method that you can to test that idea is great. Now, the fastest method to test some things is software, and the fastest method to test other things is hardware. So for me, it's always two things at once.
Again, bear in mind that the audience also matters, because in the hardware space, it's easier to do digital and we're getting feedback in-house. If we are taking it outside where we're talking to actual customers who would be on contracts, they like to feel, they like to see. So in that context, we would be hitting a physical prototype because that's everyone is coming together in maybe a space, and then we are looking, dismantling, checking, engaging. That suits that purpose. So like he said, there's no defined either this or that, or let's do this. Do what works for the audience.
Okay.
I would say also to sort of layer in on that, this gets into some of the space of cross-functional work is the phrase that we use in the Agile. And a lot of people don't think that cross-functional is possible or that we don't need cross-functional teams inside of the hardware space. But it actually works the opposite way. Every time we've gotten a team together that has, it has a tester, it has an indus personnel, somebody who's going to be doing some building, somebody who's going to be doing procurement and supply and the engineering, mechanical and electrical engineering, as well as product design, all together in the same team, meeting on a daily basis, we start to realize that there is work. And I think this goes back a little bit to what you were talking about earlier with the difference between Agile and Waterfall. And that's one thing that I would say in the way that Waterfall was set up is it created this mindset that we don't need the people at the end of the project yet. So we're not going to even hire them. And they're off in other teams and they're not available. And so the engineers are doing product people are doing some design before the engineers have even gotten involved. And then the engineers are doing all the work, the digital twins and figuring out all that kind of stuff. And then they hand it over to the mechanical people and then the electrical people, and they hand it over to the industrial people, which hands it over to the factories or it's, supply chain in the middle of all of those things. And that was the waterfall kind of process. We just broke that up entirely. And so there was an idea, and the indus people and the supply chain people could jump in right away when the idea comes up and do some research and come back and say, good idea, bad idea. And then the engineers got in and they had some other things to do. So the only reason under a waterfall method that these teams weren't doing this is because those people hadn't been assigned to this team yet.
Yeah, right.
When we started with what we called our cross-functional team, where we had one person from each role on that team at least, then they started talking to each other and they started working in parallel. And then work now that normally would have been spread out across the 2 to 3 year timeline was happening at the same time. And this is how we got things done in a year and a half instead of 3 years. Because the people were there and they did the work at the same time. There's always work to do.
A common phrase you would hear could be, that design might be difficult to assemble. But you wouldn't hear that if you just did a handoff and you said bye. Well, plus he was there at the beginning and maybe they had done the first 2 weeks and done a concept design. We're showing it like, it might be easier to assemble if you probably take this out and add it here and then okay. Because now he's thinking of the end while you're at the beginning because he was opportuned to be there in one thing.
Mhm. So
If
this
I
is
could
really
add in,
interesting. Yeah,
I just
go
want to
ahead.
add in
Go
really
ahead, Pete.
quickly here that at this point in the conversation with people, they usually say, "Oh, that's great in theory, but what about in practice?" And I just want to point out that we have done this in practice again and again with teams across a
Yeah.
variety of different things. I'll even toss in here that we did this with we had one organization where we were brought in to work with one department over
Yeah.
here, and the people there were like, "Nope, I'm not doing this. I wanted." They left and they moved over to this other organization, and then we went through another one, and all those people were like, "Nope, not doing it," and I'm left. And so there was this one final department that held everybody who had quit their jobs in the other departments and went over here just so they didn't have to do the agile. And they said,
Wow.
and the leadership said, "All right, we got to do this group. What can you do with these people? They do not want to do this change and this thing." And we went in with our process and we went problems first. We identified their problems. We mapped all the things out. We got all that stuff together with their actual work in all kinds of different hardware things. And we just did it over and over and over again, team after team. And they started to realize it had nothing to do with hardware. And a lot of them went back to it. And then we had people who had been there for like 30 years and they're like, "Oh my God, this is the way we used to build products." And then
Yeah.
somebody came in and changed it and we stopped. And somebody came in and changed that and we stopped. And somebody came in and changed it. But like this is what we love to do. This is why I got into this job in the first place.
Get your
And we were
hands on it.
bringing them back around to that, hands on in there, working collaboratively kind of a process. And it definitely works.
Fascinating. One of the things that I'm hearing is there's definitely what I'm hearing is for an organization, you definitely need a competency around this prototype lab that's cross-functional, right? You need representation from basically everybody that would be involved in actually making the product, getting it up front. There's also a shift to kind of hands-on making it with engineers. Um, so that's new, and frankly, that's kind of substantial. I mean, that's a big change, and in it, we talk about there's so much discussion around digital transformation um, nowadays, right? But this is a transformational change that looks very, very different, and digital is a component of it, but it's much more about you know the way you work, and higher level outcomes like sprints, and we're going to end up with a prototype at the end of this, a functional prototype at the end of this thing that you can show to your customers, that you can test. You're going to learn a lot more. You're going to discover unkunks, and that just feels very, very different. Has that been a stumbling block with some executives to say, "Hey, this is going to look and feel different"?
I think that yes, the answer is very quickly a yes on some of that stuff. We work with each organization to make the change in the way that the organization can handle it. It'd be awesome if we could just walk in and do all the things that we know how to do from the ground up, in the beginning. But that
Yeah.
usually only happens with somebody that has worked with us in the past and is like, "I know this works. Trust me. We're going to do this way from the very beginning." But usually what we do is we come in, I have a phrase that I use, which is how you introduce a new idea is more important than which idea you introduce.
Okay. Yeah, I
And
like
so
it.
even all of these things that we're talking about doing, it would be too much and it would freak people out. With the organization, the first team that we do, we're tackling what that culture can sustain for change right now and fixing some of the problems for them. And then based on that, other people see that success and they're like, okay, I'm willing to try it. And then we add more in the next team, and then we add more in the next team, and then we add more in the next team until the culture has made a shift. And now the next team is like, "Give me all of it." But we very seldom get the first team saying, "Give me all of it."
No, that's really fascinating. Good stuff. Okay. I want to shift gears again to talk a little bit about a different concept in Agile. You tell me how much it applies to the hardware side of things. So the idea of, okay, we're going to create tickets. Ebele, you had a sticky note on your wall behind you, right? So the oldest school concept of this from the software world is a bunch of sticky notes all over a wall, right? And a software developer walks up, grabs a sticky note from the to-do list, takes it to their desk, slaps it on the desk, works on it, gets it done, takes it up back to the wall and puts it in the, the done list, right? Can you, and I want you to talk about this in the context of kind of at least in my mind, the old school engineering ownership of designs, right? It used to be that when you're an engineer and the component was released, you put your signature on the drawing. And if something went down, they were coming to your desk, right? And you owned it, right? But in this world of, tickets or sticky notes, I'm going to take it back to my desk, put it on there. You don't know what you're going to work on next. You might be working on a small component of a bigger thing, right? Because you're just discretizing it down further. So can you talk to me a little bit about the process? Does it apply to hardware? And I'd love to hear your color commentary on engineering ownership and accountability, and how that plays out from a cultural perspective.
So that's a very good question, because one of the problems we've seen the most is, what do I work on? And after that, what next? But people called out something earlier, which was specialization in hardware. In software, you could have a full stack developer doing almost any part where they could just pick a ticket, what need. In hardware, we face more deep specialization. The person who does quality across. And that's all they do. The person who does thermal testing could just be doing thermal testing. Because for you to understand how to do thermal testing, you probably have to do 10 years plus of specialization training. So in the hardware space, it's easier to build out the roadmap for you to see what you are doing now, what you will do next week, what you will do at the end of the quarter, because there's visibility into the work. So there is no unknown tickets. Everyone knows the work, and we color code it such that you would see on the board, oh, this is for engineering, this is for quality. Even if you're not a part of the team, you can tell which is quality work, which is engineering work, all through the way to deploy. It's a living document, though. We can update it as the new information is coming to say, okay, let's move this. At the end of each sprint, we come back to the board. Which one was done? Which one needs to be pushed out? What is the effect of the push out on the timing? And what is the effect on this risk or that risk? But the point is, everyone knows with IDD, because before IDD, it was a problem. They knew who was supposed to do it, but the person didn't know which work to do, like when. Which one was the most important work? That's the most, right.
Yeah, I came to this as a architect. So from being an engineer up to an architect, so I was building entire systems, or at least I was mapping out the entire systems, and the other people were building it around. So I already had this process of figuring out where all the pieces were and how all that stuff came together. So when I came into the software world and these agile teams, and they had things in product owner be like, okay, you're going to build this, you're going to build that, you're going to build this, here's your sticky note, go work on this. And those little bits of things might take 2 or 3 days. I was like, where did that sticky come from? How did you come up with what's right on that sticky? Because that was my job before. And so then we'd sit down and talk about stuff, and they were like, well, I just figured this would be a good feature to add. And This is something that came up in sales. And so they just write it down. And the idea of the user story was, here's something I want the user to be able to do. Here you go,
Yeah.
go make it happen. And in software, it was fast enough that people could turn those things around in a week or 2 weeks. And so
Mhm.
nobody thought about, are we building the right stickies and are we giving them to the developers at the right time?
Yeah.
So hence this getting into the mapping process. So what I did as an architect is I mapped out process maps of all the different things. And a lot of electrical engineers, mechanical engineers, have to do the same thing. And that's part of my training, but that was brand new for software. So the sticky note can translate to hardware, but you have to know where it comes from. And that was one of the things that we were doing with teams in the manufacturing space, is we were doing these process maps that I used to do as an architect. But I had experience as a product. So I would go all the way to the point of sale and say, all right, where are you selling this? And they're like, oh, well, we're gonna sell this at the end. We got some salespeople. No, I mean, like, who are the salespeople talking to? No, where is it? Like, and I'm like, and I was like, no, we're going all the way. Okay, so somebody goes into Home Depot and they grab this product, they put it in their basket, and they walk home. Okay, where does Home Depot get it from? And then backwards from Home Depot, where does the warehouse? They get it from a warehouse. The warehouse puts in the orders from a central redistributor. The redistributor has to place certain orders. Those orders have to come from the various different factories. We map that whole process working backwards with the whole team. And the backwards is super critical. This is one thing I learned as an architect, was that when I built my designs forward in time, they were always less efficient than when I work backwards in the future. I would imagine what's going to happen in the future, and then I'd work backwards from there and say, what do I need to do now? And when you map that process together as a team with your indus people and your testing and your verification and your supply chain and your engineers and your product people all building that map together, you start realizing where the sticky notes come from. And all the pieces start to lay out. And then we lay it on a timeline and we say, all right, how long is it going to take to do this component of the flow and that component of the flow? Because we know that has to be done before this is. And we get a critical path to say that we're never going to hit our date unless this happens in this week and that happens in that week and that
Right.
happens in this week and this happens in this week. So if this one shifts, everything else is shifted. And we need to readjust. And it got us to that point of the team knew where the stickies came from because they put the sticky up there themselves.
Yeah.
It wasn't a product owner handing over a sticky note to them saying, build this, which was possible in software, impossible in hardware, which is why they came up with a better process in hardware.
Very interesting. That's fascinating. Love that context. I love that answer. Okay, let's shift gears again. You talked through the example of a smart connected product, and some people might listen to that and think, "Oh, that's simple. It's a very simple case." We design really super complex systems. That complexity would overwhelm that process. So talk to me a little bit about how this approach can scale up to higher levels of complexity, software complexity, hardware complexity. How does it work there?
Let me offer this idea and then tell me if this is what you are actually asking. Which is that we ran into this in a couple of different places. Again, my architecture thinking that scaling down is better than scaling up. And here I'm kind of thinking as a physical product. So we ran into a place where we had multiple different versions of a product that evolved, over time and over years. So one was the basic version of the product. The next one was the version of that product with a few extra features added on. The next one was the much more advanced thing with, a introduction of some logic engine. And then there was another one that was the introduction of a smart connected IoT Internet of Things device and working on these things. And because of how they had evolved, they were each different teams. They each had different architects, and they each were designed in a different way.
Wolf.
My architect brain is like, we should design the integrated smart one first, then take out the smart stuff and do just the logic version, and then take out the logic version and then just do the dumb version, and take out that complex version and just do the simple one. Because now you can share parts across the entire product line, which is cheaper. You've already have them. You already have relationships with your suppliers. They've already gone through the design process. When you think about the entire life cycle of a manufacturing process, sometimes the opposite order of design results in better industrialization and better production. So again, that's why I always work backwards from the future. Go out to the end. Where do we want to be eventually? Then let's work our way backwards from that, and then look at the optimization for the entire line, even though we might build one process in a part and then another, and we wouldn't do the whole thing right now. But there's a big difference in productivity if you've got one team working on the hardware piece, and you know that the smart version of it is just going to take what they build and integrate it with the cloud. Now, this team doesn't have to rebuild their own architecture with their own supply chain, with all of their details of the product for the smart thing. They collaborate with the team that's doing the dumb version of the product.
Mm-hmm.
And now you get two products out much faster than if each was building
Separately.
and designing their own products from the ground up. So my brain reverses what your question was. But if I did not answer your question, let me know and I could adjust it.
But then again, Pete, to Pete's point, the complexity that they face in hardware is the reason Pete and I are like, we know that this problem is faced practically everywhere and we've solved it. The view is in the opportunity to see the whole picture is what is lacking. And the minute they can see it, Peter and I can actually walk away. Because once you put them together to the point where they are able to build that system view of the roadmap from product to deploy, at that point we could say, hey, goodbye. Because then with that view, they are able to iterate, plan and replan, update, and just make common sense of the whole nonsense. Because that whole information could be sitting in someone's head. Maybe the project, we had a project where it was just a project manager that had that view. He knew what was working, but he was finding it very difficult to translate that to the team members. But when we had the session, it's always a very tough session, pulling all of this information off of everybody's brain, dumping it for a shared view. But the minute we did that, it was like, this is exactly what I've been trying to communicate.
That's great.
If he had the opportunity to have done that at the beginning, I would have saved him years.
Mm-hmm. Yeah. Yeah, really good insight. Thank you. Really appreciate that. All right. So this has been a fascinating discussion. I mean, thank you all so much. Let's close it out with a standard question we've been using recently. So if you could redesign anything from culture to, I don't know, a movie to a product, what would it be?
My first thing is starting with the problems. So prioritizing the problems together as a team. What are the things that we want to solve? Because if we don't, the solution to one problem often creates or makes another problem worse. So the first thing I would do in any design project, whether it's a coffee mug or a corporate culture, is get together and say, what are the problems that we're trying to solve? And if we can't solve all of them, what should we not make worse in trying to solve another problem? And once you have that, the rest of the life becomes much easier.
What Pete is also trying to say there is, what problems, we're referencing all functions. Is that problem faced by architecture? Is that the same engineering? If we are building one product, what problems are we? Because sometimes you could have, we've experienced it a lot, diverging incentives.
Mm-hmm.
So once we can sync everyone to the common problems and we order them, that's prioritize them, it's easier to take decisions because we know that this is the number one priority we're trying to solve. So that goes first before we give architecture what they want, because architecture wants is sitting at number 3. So prioritized problems, and most importantly, is the people. The people happiness is a major factor for me, because no matter the shiny new tool that you bring, it's still people that would use it. So people happiness metric, what are the things, what are the problems these people are facing? Let's solve them. Let's have happy teams, motivated people working together.
Excellent. All right. Well, Ebele, Pete, thanks so much for your time. Really appreciate it. Great discussion. And for everybody listening or watching, thanks for your time. Take care. Talk soon. See you on the next episode.
Thank you, Jeff.
Thank you so much.
Thanks for tuning in to today's episode. If you enjoyed the conversation, make sure to follow or subscribe on your favorite podcast platform so you never miss an update. We'd love to hear your thoughts. Send us a message, leave a review, or join the discussion on our social media pages. Until next time, take care and talk soon.